So, the commutative property. This is not really the way that I would do it, but this is a really nice, nerdy way to say it, okay? Is if you saw something like this, 7x times 3x to the power of 2, you can actually, because it's all multiplication in here, even between the parentheses is multiplication. Multiplication is the only operation you do not have to always show. So if you don't see an operation, just know that it has to be multiplication. So you can see, though, that now that we know it's multiplication, you can actually show it with multiplication and kind of move stuff together that probably belongs together. By the way, this would be considered one full term. It's just got lots of factors. So you'd say, well, move the numbers together so you can multiply those, right? Okay, and that's nice because 7 times 3 is 21. And then an x with another 2 x's really is just, if we go back to exponent rules, it's 1 plus 2, which is 3. And that's how we get this final monomial, I guess. Like I said, though, I probably wouldn't look at it like that. Like, I just say 7x times 3x to the power of 2, and then I know 7 times 3 is 21, and x times x to the power of 2, again, that's 1 plus 2, which would give me an exponent of 3. Do you have to do it like this? No. If you like the first way, do it. If you don't like the first way, which most students don't. You'll never be required to do it a specific way. Again, for me, I just like to focus on the numbers first. All right, let's see if we can do it this time. 5 times 3 is 21. All right, so 5, no, you're good. 5 times 3, not 21. 24. Almost. 15.
51.
Almost. It's,
Sorry.
some dyslexia maybe right there, right? Now, I've done that, right? So I like to actually do this one part at a time. Focus on numbers, focus on your x's. If we find that there's y's in there, I separate the x's and the y's, do them separately, okay? And by the way, I'm showing probably more work than most of you would. Okay, whatever. So then we've got the x and the x to the power of 4. Again, it's a base x, but then the exponent's 1 plus 4 is 5 right there. So that's simplified, and yeah, I did the addition right at least. As usual, it's like, oh, that'd be nice if all the problems were like that, but it's not going to stay that way. So when multiplying monomials by binomials, trinomials, or polynomials, we just use distribution. Pretty much we're always going to use distribution. If you've heard of FOIL, it's still distribution. That's all it is. So let's take a look. Yeah, like this one, right? Here I have a 3x to the power of 3 to distribute to all 3 terms. So that's a monomial now distributing into a trinomial. Again, I'm going to show probably more work than you'd ever want to on an exam or any other time, but I hope it helps. So I'm going to take my 3x to the power of 3 there, and I'm going to multiply it by 5x to the power of 2. Now, like I said, I would keep these separated, and this is just for one individual term. There's just lots of factors with it, right? So I'd say, well, 3 times 5 is 15. Then I've got my base x, and then the exponents 3 plus 2 would be 5. Why am I adding those? Because we're multiplying the bases, the same base, I should say. Next up, I have the 3x to the power of 3, but I must distribute it, so that's multiplied by the negative 6x. So again, just with the numbers, 3 times negative 6 is negative 18. And then this other x has an exponent of 1. My base x has an exponent of 3 plus 1, which is 4. And finally, and then, yeah, 3x to the third times 4. Again, I would just do 3 times 4, which is positive 12. And there's no other x's to multiply with that x to the power of 3, so it just stays x to the power of 3. And unfortunately for us, we had so much fun, this one's over. I feel like you want to. Okay, so combining like terms. By the way, I would never show combining like terms like this. Again, this is a very nerdy way to show combining like terms. If I were to combine like terms, I would take the 5x's and 2x's, as you've seen, and I'd say, how many x's do we got? 5 plus 2. See, and this is just a different way to show the same exact thing. This is 7, okay? Now, some of you would say, you just factored out the 5 and 2. Okay. Or I factored out the x. Oh, okay, so, sorry, that's pretty nerdy of me. I apologize. In any case, so this one right here, this is like saying think about it like this, okay? If you had 4x's plus 3x's, you could just say, how many x's do you got? 4 plus 3, right? Oh, crap. 4 plus 3, which is 7. This is the same idea. It's just now instead of an x, it's an x plus 1. Right there. And you can do that because they're factors, right? So x would be a factor of this term. X plus 1 now is a factor of this term. Now, be careful, because some students are like, I want to distribute so bad the 4 and the 3 right there. That's not what I'm trying to get to. You could. I just don't want you to do that right now. I'm just trying to get you in the idea that you can combine these like terms. 4 and 3 of these would be 7 of them, right? And then you could distribute just once. Maybe that last part is not really what I want there, but this is kind of what we're looking at, right? So the same principle applies when we would make a polynomial of the 4 and the 3. Yeah. So what's going to happen here is maybe this 4 has an x right there, okay? So again, we're going to say, let's split it up. And then I'm purposely going around FOIL because I hate FOIL.
What?
Okay, so that last part, this is what I'm talking about right here, right? So we're looking at that stuff of combining like terms now just kind of in reverse. So like this 4x right here, we're going to take it and multiply it by this full other, it's binomial. It could be a trinomial, maybe it's even a monomial, it doesn't matter. You can distribute this 4x into this other binomial, but we're going to do the same thing with the 3, right? Now I'm showing it deliberately as two separate multiplications right here just to relate it to what we just saw. Again, some students, and if you do prefer this, again, I never require one specific strategy, but some students are like first, and that's what I'm getting to right here. Some students say, there's my firsts, there's my outers, there's my innards, and then lasts. So all that multiplication kind of skips down to this line, and then you get this one, and then usually those two middle terms, usually you can combine them, although not always. So just FOIL is great, first, outer, inner, last. It is convenient, but again, if you're like, I just like the distribution thing, all right, because that's really what's happening with all this. I would prefer not to say FOIL and just say, look, distribute and be done with it. So, all right, so here we go, right? Now, I'm gonna do something that looks like FOIL, but I prefer to call it distribution. I don't really care what you call it though, all right? So I'm going to distribute the 2x to the 4x first. After that, then I will distribute it to the 4. But first, let's just distribute 2x to the 4x. Distribution is always multiplication. So right here, 2 times 4 is 8. And then we have x times x, which would be x squared. You could just say, I've got x to the power of 1 twice, add the 2 ones in the exponents, and call it x squared. It's the same thing. Next up, we've got the 2x times just the positive 4, and it is okay for that to happen. Some students say that those aren't like terms that you can combine. Well, if we were adding, that's true, but we're multiplying now. So I'd say 2 plus 4 is positive 8, so there's my positive sign, and then there's just the individual x. Now I will distribute, this is a negative 2. Negative 2. I meant for these to kind of fall underneath each other, but here we go. Negative 2 times 4x's would be negative 8x's. In my heart, something feels like it's off, but it looks like we're good. Yeah. And then finally, just negative 2 times 4, which is the constant negative 8. So we have a 4-term polynomial, and we have these two like terms on the inside. How many x is that? 8 minus 8, boom, 0 x's. So now I've got 8x squared, we'll call it a plus 0x, and then minus 8. Personally, I'm okay with this because it does declare how many x's there are, but on the assignment, it's likely that they won't accept 0x because it's not fully simplified. So yeah, I know. Here we go, some extra writing for us. I hope we can, deal with it, but I don't know.
Will you accept?
Okay, so this one, let me show you a common mistake on this. So this is a mistake I hope you never do. just to clarify that this is actually a mistake, I'm going to write up here, this is a mistake. It's not really that common, but it's common enough where it breaks my heart because it's like, it's now 5 points and you just lost 5 points on an exam because of this, right? So we get so used to this distribution stuff with FOIL or whatever you want to call it, that students are like, hey, distribute the 2 in here. Now it's 6 to the power of 2 is 36, x to the power of 2, 3 times 3 is positive 9. Boom, I did it, Mr. Sell. It's like, nah, you did something, just not the right thing on that one. So never, ever do that thing. Points, you know what I'm saying? So yeah, this one, it's not x, but it's to the power of 2. Exponents are repeated multiplication. So we are going to take that 6x to the, plus 3. There we go. And we're going to show that it's being multiplied by itself, which is kind of what they want you to do anyways. So don't distribute that exponent of 2. That's not what you should do right there, okay? Well, now that we got that, let's go ahead and start our fabulous distribution here. Starting with 6x times 6x's. So again, for me, the numbers, 6 times 6 is 36. X times x, or exponents 1 plus 1 is 2. So x to the power of 2. Now distribute the 6x to that positive 3 right there. Sorry, that's a times a positive 3. So 6 times 3 is positive 18. And then we just tack on the x there. Now we got 3 times 6x's, which some of this may seem familiar because it is the same binomial, but 3 times 6 is positive 18. And then we keep the x. And then finally here at the end we have 3 times 3, which is positive 9. Now again, that's the distribution, which we should always do first when we're simplifying expressions. But now that we've done the distribution, is there any like terms to combine? Yes, there is. We got a bunch of x's, 18 of them, plus another 18, which is positive 36 x's. And then everything else can just drop 36x squared plus 36x plus 9. Now, here's another thing that I hope you don't find interesting, but I'm going to say it anyways, is math people over time have done this so many times, that they found a pattern. And if you saw something like this, you could take a shortcut if you knew the pattern. But that's not till tomorrow. So this one, sometimes students see this and they're like, oh, you know what, I quit. It's like, it's not that bad. It really isn't that bad. So don't let this intimidate you. Just work one part at a time. So some students like to just work with the 2 binomials, get your what will be a trinomial looks like, and then distribute the 2a. I personally am just going to distribute the 2a first, which means right now, I'm not even worried about that other binomial. We'll see it. We'll see it. Okay, now I've covered that up. We'll see it again. I just don't care about it right now because I'm not working with it. So work with one part at a time if you can, right? Split the problem into smaller, more manageable parts if you can, like I've just done right there. So right off the bat, I'm going to distribute 2a's right here. 2a times 2a would be 2 times 2 is 4. A times a is a squared. So I am skipping a little couple steps here, I think. Then 2a's times 8 would result in positive 16a's. And that's just from that multiplication right there. Now you'll notice I'm going to put this in parentheses, and now I will uncover that other binomial, which is a minus 4. Okay, so now we just have more stuff to multiply, some more distribution. FOIL if you want. So let's get started then. 4a squared times an a. You could say 1a if you like. 4 times 1 is 4, and then a squared times a would result in an exponent of 3. Now I got 4a squared times negative 4. 4 times negative 4 is negative 16, and then the a squared remains. Now we got 16a positive times just an a, so it's positive 16, and then we got 2 a's right there. So it's an exponent though, right? So again, if you go back to exponent rules, 1 plus 1 is 2, and then finally 16a's times negative 4 should, 16 times negative 4 should be negative 64, and then keep the a. So again, we see the two middle terms are combinable. So let's go ahead and combine those. So yeah, a squared, right? I didn't expect this to happen. But negative 16a squared plus 16a squared is going to be 0 a squared. Again, it's kind of unusual for that to happen. Expect that term to exist most of the time, but perhaps not now. So 4a cubed plus 0a squared minus 64a. And then, yeah, just to make everyone feel good inside, 4a cubed minus 64a. You know what? You guys try this one. Take a minute and try it out. All right, let's see what we get. So distribution now, again, though, we're distributing into many terms at a time, and that hopefully that's okay. So that's x times x squared. Again, we got the same base. There's no numbers really to multiply, but the exponents are added, x to the power of 3. Then I've got x times the 3x's next. So if we do have the positive 3 there, but then again, it's just x times x. So that's x squared. Then we've got x times positive 4, which I'm just going to write as positive 4x. So that's the first set of distribution. I'm going to show the second distribution a little different. I'm going to show it above just because it doesn't matter. It does get a little cluttered, but I don't know. It's still pretty for some reason. So next up, I've got negative 2 times the x squareds. So that's negative 2x squareds. And then negative 2 times the 3x's, which would be negative 6x's. And then negative 2 times positive 4, which is negative 8. So this is my new expression, but without any distribution, right? So we finished the distribution. Is there any like terms to combine? There is. We got the x squareds here, and that's 3 minus 2, which is positive 1. And I'm putting the plus sign there on purpose to kind of prepare for what's next. And then we got x terms of 4 minus 6, which is negative 2 x's. So the x to the power of 3 didn't have anything to combine with, so it just drops. Same with the negative 8, it just drops because there were no other constants to combine it with. And that's it. Again, just a quick note. If you didn't want to show the 1 there and make it a phantom 1, that's fine. Like, I didn't show the 1 with the x to the power of 3 either. It doesn't matter. Applications, area of rectangles is length times width. Hopefully that is nothing new to us. But now instead of them giving us numbers like 5 centimeters and 10 centimeters, we're expecting the length and width to be expressions, binomials, mostly. So if that happens, then we're going to set this up as length times width, and then we'll use some distribution, like this one, right? So we got... doesn't really matter which one you say is length or width, but I'm going to take the left side, the 4x plus 6. I'll put it in parentheses because I'm expecting to multiply it by the other one, which is 4x minus 6. And the truth is, if you had, I think I can do a better parentheses most of the time. That's okay. The truth is, it doesn't matter which order you put these in because that's the commutative property of multiplication. I also think you don't care. So now that we have this set up, oh, I should have read the problem. Let's make sure I'm doing this right. Find a completely simplified expression for its area. I was worried it was going to say perimeter, which would be addition, but that would be more like 4.1. All right, so we're ready to distribute. I'm going to multiply the 4x by 4x. So 4 times 4 is 16, and x times x is x squared. Because we're foiling it up, man. So 4x then times negative 6. 4 times negative 6 is negative 24. That's how many x's we have. And then, yeah, you can do it underneath if you like, but 6 times 4x's there is positive 24 x's. And we'll come back to that. But then finally, 6 times negative 6 is negative 36. So right here in the middle, I'm going to show this a little differently just to save us some time, but those two middle terms are going to zero out. And you'll find that if you have an expression like this one or a binomial, and the other one just kind of has the opposite sign in between. The two middle terms essentially go away like they just did. So we end up with 6x to the power of 2, and then we have the negative 36. That's it.